You're welcome back. And in this lesson, we're going to be solving this system of equation. We have x raised to power 3 plus y raised to power 3 equals 2. And x raised to power 2 plus y raised to power 2 equals 2. Well, trust me on this one. This is not an easy equation to deal with. It seems like an easy one, but most methods would actually lead to a dead end. So, but we are going to solve this using probably the easiest method possible. Okay, so let's get right into it. The first thing you should do at this point is recall that when you have x plus y to the third power, when you open this bracket, this is going to be x raised to power 3 plus 3 x y, x raised to power 2y, and plus 3 x y raised to power 2 and plus y raised to power 3. And from here, you will notice that if you put this part together, x raised to power 3 plus y raised to power 3, you can factor 3s out of this. You can factor 3sy out of this. And when you factor 3sy, you have x plus y. You have x plus y there. While on this side, you have x plus y raised to power 3. If I bring all of this on this side, I'll be having x plus y to the third power and minus 3xy and multiply by x plus y and equals x raised to power 3 plus y raised to power 3. Do not forget this. Do not forget this. We're going to need it, okay? So next, if you open the bracket x plus y raised to power 2, this is going to give you x raised to power 2 plus 2xy and plus y squared. And from here, if you subtract this 2xy from this side, so you're going to be having x plus y raised to power 2 and minus 2xy, and that's going to be equal to x raised to power 2 plus y raised to power 2. So we're going to need this too. Let us replace what we have in the equation here with things we have here. And what would that be? So this becomes x plus y raised to power 3 from here, and minus 3xy into x plus y is equal to, we have 2 here. So you know what? Let us be calling this one equation, let's call this equation 3. We should call this one equation 1, and let's call this one equation 2. Okay? So let's call this one 3. Now also the second one here, which used to be x raised to power 2 plus y raised to power 2 equal to, becomes x plus y raised to power 2 minus 2xy equals 2 as well. So let's call this one equation 4. Now at this point, you'll notice we have x plus y and we have xy. What we are going to do is let x plus y equal to something like a, okay? And let xy equal to something like b, okay? And when we do that, this equation then becomes a raised to power 3 minus 3. This is a and this is b, so I'm putting ab here equals 2. And a raised to power 2 because this is a, right? And minus 2b equals 2 as well. What we should do is let's call this star and let us call this hash. Okay? Now we have this system of equation to deal with. Now this one is much easier to deal with. So I think we should start from this smaller one. Okay? A squared minus 2b equals 2. And from here, so if you subtract a squared from both sides and divide both sides by negative 2, you will be having b equals 2 minus a squared and divided by negative 2, right, from here. So let us put that value for b in the star here. So we are going to be having a to the third power minus 3a into 2 minus a squared divided by negative 2, and that equals 2. So let's open the bracket here. So we have a raised to power 3 Let me leave this negative here for now. 3a multiplied by 2, that's 6a, and 3a multiplied by negative a squared, that is 3a to the third power, and all divided by negative 2. I'm closing that bracket, and it's equal to 2. So next is to make this linear. I'm supposed to multiply both sides of this equation by negative 2. If I multiply both sides of the equation by negative 2, the equation will be linear. So multiplying this by 2, this becomes, by negative 2, we have negative 2a raised to power 3. And this remain. I'm multiplying this part by 2. This negative to cancel out this. So we have negative into 6a minus 3a raised to power 3. Let's close that bracket there. And all equals 2. And all equals 2 multiplied by this. This gives negative 4. So let's open this bracket. We have negative 2a raised to power 3 minus 6a and plus 3a raised to power 3 equals negative 4. And from here, we combine this and we have a raised to power 3 and minus 6a equals negative 4. And when we bring this here, it becomes a raised to power 3 minus 6a and plus 4 equals 0. Well, how do we solve this cubic equation? Well, let's use trial and error method. It is reasonable to test when we're using the trial and error method to start testing for factors of 4. So the factors of 4 the factors that can go through in 4 include 1, 2, and 4. So let us test for plus or minus 1, plus or minus 2, and plus or minus 4. So let us test for plus 1 first. Let's test if a is equal to 1. So let's test if a is equal to 1. Then this will be 1 raised to power 3 minus 6 into 1 and plus 4. So looking at this already, this is not equal to 0 because this and this will be 5 and this will be negative 6. So what if a is equal to, what if when a is equal to 2? Let's try that too. So this will be 2 raised to the third power and minus 6 multiplied by 2 and plus 4. So this is 8 and this is negative 12. Yeah, this should do. So this is 8 and minus 12 and plus 4. This is equal to 0. So we know that this holds true. So since we know that a is equal to 2, then a minus 2 is a factor. It's a factor of the equation. Well, at this point, let us go on and use this factor to divide the quadratic equation. We have a minus 2, and we're going to use this factor to divide through this cubic equation. So, but I'm going to put down a raised to power 3. We don't have a raised to power 2 there, so I'm going to put 0 a raised to power 2, and then we have minus 6a and plus 4. Okay, so and the reason why I put this here is so that the whole thing can be in order, and so I won't make mistake as I compute the thing. So a in a raised to power 3 is a squared. I'm putting that here. So multiplying this by that, we have a raised to power 3. I hope you know how to do this already. Negative 2 multiplied by a squared gives negative 2a. Next, we go on and subtract this. So this is gone, and negative 0a squared minus 2a squared, this becomes positive. So we have 2, and this is squared. We have 2a squared. Let me bring this down, minus 6a. Next, how many a can we get in 2a squared? That's going to be plus 2a plus 2a. I multiplied by that gives 2a squared, and minus 2 multiplied by plus 2a squared gives minus 4a. We are subtracting again. This is gone. Negative 6a minus 4a. This becomes positive, and that's going to be negative 2a. Next, a here is negative 2. And a multiplied by that gives negative 2a. And negative 2 multiplied by negative 2 gives positive 4. we are subtracting again. So subtract 4 from 4 is 0, and subtract this from this 2 is 0. So the cubical equation is now reduced into a minus 2 equal, a minus a raised to the power 2 plus 2a and minus 2 is equal to 0. So here it's either a minus 2 is equal to 0, such that in this case we have a is equal to 2, and also a squared plus 2a minus 2 is equal to 0. Well, we can go on and find the value of b when a is equal to 2, but I'm curious. Let's check out this first, okay? So this quadratic equation, let's solve it using completing the square method. First, we bring this on this side, right? Then we find what must be added to the other part there to make it a perfect square, right? So this becomes a raised to the power 2 plus 2a equals 2. And what must be added to this part to make it a perfect square? So square half of this. Half of this is 1. Then you square it. So we have a squared and plus 2a plus 1 squared equals 2 and plus 1 squared. Such that here, when we multiply 1 by 1, it gives us 1. And when we add 1 and 1, it gives us 2. So this is a squared plus a and plus 1 equals 2 plus 1 is 3. So when we factor this part, we have a into a plus 1, right? We repeat a plus 1, because as long as you get the first one, the second one will be correct, will be right. It's equal to 3. So this is a plus 1 squared. I shouldn't be wasting time with that. Now, to obtain this, we square root both sides. We take the square root of both sides, and a plus 1 is equal to square root of 3, such that a is equal to minus 1 plus or minus square root of 3. Well, if we are going to be sticking to integers so that we don't waste a lot of time working on this, okay, because the video is getting lengthy already. So let us focus on these integers, okay, the value for which a is equal to 2. Now, when a is equal to 2, what is b? So we use this first equation star here to obtain all of those solutions. So let us make use of the second equation here to obtain the value of b. So we have a raised to the power 2 and minus 2b is equal to 2. So we have our a is equal to 2, so I'll put 2 raised to the power 2 minus 2b is equal to 2. And from here, this 4, we bring it on this side, and we divide both sides by negative 2. And b is equal to 2 minus 4 divided by negative 2. So this is negative 2, right? So b is equal to 1. So b is 1 when a is 2. So it's time we go back to where we set x plus y equals a and xy equals b. So we obtain another system of equation. And now we have x plus y equals a, which is 2, and xy equals b, which is 1. From here, let us find x first, such that, let me call this one, what do we call it here? Okay, we have not given it a name. Let us call it 5, and let us call this 6. So from 5, y is equal to 2 minus x when we subtract x from both sides of the equation. And when we put this here, we have x into bracket 2 minus x is equal to 1. Opening this bracket, we have 2x minus s squared is equal to, let me bring this on the other side, right? So 1 minus 1 is equal to 0. If I write it properly, to be negative s squared plus 2x and minus 1 equals 0. Okay, I should get rid of this negative here, and this becomes x raised to the power 2 minus 2x and plus 1 equals 0 when I multiply both sides of the equation by negative 1. Well, this can be factorized. We can use the factorization method to solve this. So because 1 times 1 is 1, and 1 plus 1 minus 1 is minus 2. So this is going to become x raised to the power 2 minus x, and plus 1 equals 0. And from here, we have x into, x is common here, so we have x minus 1. Let me close that bracket there. And let me repeat x minus 1 here. So there will be negative 1 on the outside here. All equals 0. So we have x minus 1. I hope that is not out of the camera. We have x minus 1 squared. You have x minus 1 is equal to 0. So it's clear that x is equal to, x minus 1 is equal to 0, and x is equal to 1. Okay, if x is equal to 1, then what is y? We use the second equation here, so let's use the first one here. Since x is equal to 1, we have x plus y is equal to 2. And we are going to put 1 here, so we have 1 plus y is equal to 2, and y is 2 minus 1, which is 1. So y is equal to 1, and s is equal to 1. Well, you can go on and try for the value of b when a is equal to negative 1 plus or minus square root of 3. So then you go on and obtain all that possible solution for the problem. Well, it's a cool one. See you in the next one.